some properties on linear transformation. So the first property is if T is a mapping from V to W is a linear transformation is linear transformation then prove that T of 0 bar is equal to 0 bar. So if T is a linear transformation, then under the mapping T, the 0 bar maps to 0 bar. This is what we want to prove here. So for example, if we consider an example, say here, consider an example. If we consider here, say T of x y is equal to x plus y and y. Say this is a linear transformation from T is a mapping from r square to r cube is a linear transformation. So if we consider here 0 bar is equal to 0 0 in r square. So we are going to check whether it maps to 0 bar in r square. So under the map T, so T of 0 bar is equal to T of 0 0 is equal to 0. The what is mapping x, so it is 0 plus 0 and 0, so it is equal to 0 0 0 and it is nothing but it is equal to 0 bar in r cube. Okay, so if T is a linear transformation, then T of 0 bar is equal to 0 bar. So given, now since given the function T from V to W is linear transformation and our claim is, that is we want to prove that our claim is prove that the T of 0 bar is equal to 0 bar. So now from vector space theorem, as we know that since 0 into u bar is equal to 0 bar, 0 into u bar, and therefore T of 0 bar is equal to T times 0 into u bar. Since 0 is a scalar, since T is a linear transformation, so as we know that if T is a linear transformation, then T of alpha u bar is equal to alpha times T of u bar. So here we can take this 0 outside, so it is T of u bar, but again 0 into u bar is what? 0 into u bar is 0 bar, so 0 into, say this is u bar, so 0 into u bar is equal to what? 0 bar. So therefore T of 0 bar is equal to 0 bar. Now next, property number 2, the T of minus u bar is equal to minus T of u bar. So again, if u bar is a additive inverse, u bar is the inverse, additive inverse of minus u bar is additive inverse of u bar, then minus tu bar is inverse of additive inverse of tu bar. This is what we want to prove here. So consider an example. Suppose if we consider a same example, previous example, what is T is a mapping from r square to r square, T is a mapping from r square to r cube, defined as T of xy is equal to x plus y and y. So if we consider here T of 1 2, then say take here u bar is equal to 1 2. Okay, then what is minus u bar here? Minus u bar is equal to minus 1 minus 2. So we want to prove that this, the what is tu bar here? Tu bar is equal to T of 1 2, which is equal to 1 plus 3 plus 2, 1 3 2. And what is minus tu bar here? So sorry, T of minus u bar is equal to T of minus 1 minus 2, which is equal to minus 1 minus 3 minus 2. So you can observe here that the T of minus u bar is inverse of, additive inverse of tu bar. Okay, so if minus u bar is a inverse of u bar, then T of minus u bar is inverse of tu bar. This is what we want to prove here. So now to prove this again, since we know that T of say, as we know that minus 1 into u bar is equal to minus u bar. Okay, so minus 1 into u bar. So we can write this t of minus u bar is equal to t of minus 1 dot u bar. Okay, but since minus 1 is a scalar, again t is a linear transformation, so t times ku bar is equal to k times t of u bar. This is L2 property. By using this, we can write this is equal to minus 1 into t of u bar, but this is minus 1 into t u bar is again what? By using this property, minus 1 into u bar is u minus u bar, so minus 1 into t u bar is equal to what? Minus t u bar. Okay, here you can observe same. What is my t of minus u bar? T of minus u bar is equal to minus 1 minus 3 minus 2. So if minus u bar is additive inverse of u bar, then t of minus u bar is additive inverse of t u bar. Why this is possible? Only because t is what? A linear transformation. So this is proof. If we now third property, t of u bar minus v bar is equal to t of u bar minus t of v bar. So again since we can write this as t of u bar plus minus v bar can be written as minus 1 into v bar. So now since t is a linear transformation, so t of u bar plus v bar can be written as t of u bar plus t of v bar, since t is a linear transformation. T is what? Linear transformation. So this is equal to t of u bar plus t of minus 1 into v bar, minus 1 into v bar. Sorry. Minus 1. This is equal to t of can write this is equal to t of what? Minus 1 into v bar. Okay, but this is equal to, so since t is a linear transformation, again t of ku bar is equal to, since is equal to k times t of u bar, and minus 1 is a scalar, so we can write this is equal to plus minus 1 into t of v bar. But what is minus? This is nothing but t of u bar minus t of v bar. So if t is a linear transformation, then t of u bar minus v bar is equal to t of u bar minus t of v bar.